In part 1, I predicted the discoveries to be made by the James Webb Telescope about the creation myth of the Big Bang and the failed gravitational model of galaxies. In this second part, I'll talk about the gulf between thermonuclear and electric star models and expected discoveries from the James Webb Telescope. First, I want to pay special tribute to an unsung pioneer of the electric universe, Dr. Charles Bruce, who lived from 1902 till 1979, an Englishman who was uniquely qualified to recognise the electrical nature of the universe, as both a Fellow of the Royal Astronomical Society and an authority on terrestrial lightning. Dr. Bruce graduated in 1924 with first-class honours in mathematics and natural philosophy. In 1952 he was awarded a Doctor of Science, both from Edinburgh University. In 1942 he was elected a Fellow of the Royal Astronomical Society, in 1964 a Fellow of the Institute of Physics, and in 1965 a Fellow of the Institution of Electrical Engineers. He joined the Electrical Research Association from 1924 until his retirement in 1967. The event which led him to the study of the significance of electric discharges in astronomy was his attendance at a lecture on The Sun and the Ionosphere, given by Professor Sidney Chapman, the leading British mathematician and geophysicist, when he noted that the velocity of a solar prominence, which reached a height of 1 million miles in an hour, was very close to that of the leader stroke of a terrestrial lightning discharge. In December 1960 he wrote an article in Electrical Review titled An All-Electric Universe. It outlines his theory published much earlier in 1944, which, and I quote, endeavours to show that electrical discharges have gradually condensed matter from the primordial gas and dust of a general universal atmosphere, first into galaxies, then from the condensed matter of the galaxies into stars. Discharges in the extended atmospheres of stars further condense the matter, ultimately to allow the formation of planets and satellites." End quote. Key to this discussion is two of Bruce's major concepts. He was the first to propose the birth of stars and planets in high-compression magnetic pinches along current channels in molecular clouds, rather like cloud-to-cloud lightning. He was also the first to propose that secondary bodies or satellites may be ejected from a star by a phenomenon observed in arc welding, where the arc pinches down on the electrodes, causing a high-pressure jet and the ejection of metal in the arc welding process. Such an ejection of matter is observed to be independent of gravity. Bruce's detailed electrical explanation for phenomena seen on the Sun relied upon comparisons with atmospheric lightning. Understandably, he accepted the thermonuclear source of the Sun's energy. Bruce's struggle with astronomers was in trying to convince them of global lightning in stellar atmospheres. The famous British astronomer Arthur Eddington had noticed evidence for stellar lightning when he wrote his book The Internal Constitution of the Stars, published in 1926, that established the standard model of thermonuclear stars. And I quote, "If there is no other way out, we may have to suppose that bright line spectra in the stars are produced by electric discharges, similar to those producing bright line spectra in a vacuum tube. We conclude provisionally that bright lines in the spectrum of a static star indicate that either A, the star is greatly disturbed by thunderstorms, or B, it is a nebulous star. But the million-degree corona and excited atoms producing the bright line spectra outside the Sun clearly show the energy is coming externally from the galaxy." Clearly, he didn't have the mathematics to deal with that. On page 1 of the book he states, and I quote, "An understanding of the mechanism of the interior throws light on the external manifestation of the star, and the whole theory is ultimately brought into contact with observation." End quote. He has fooled all the experts since. The next unsung engineering hero of the electric universe was Ralph Jurgens, who lived from 1924 until 1979. In the 1970s, Jurgens referred to Bruce's work and solved the energy problem by introducing the physics of a low-pressure gas discharge, which requires a galactic circuit to power it. His revolutionary insight was to recognize the Sun presents all the detailed features of an electrically stressed anode in a coronal discharge. He even foreshadowed my input to his model when he wrote in 1976, and I quote, "Could it be that the search for thermonuclear energy is a false trail that has been followed all these years with no real hope of success? If the Sun and the stars indeed succeed in fusing lighter elements to form heavier ones, are the relevant activities carried out more or less in plain sight, in their atmospheres?" End quote. We can generally trust engineers. They've got to make things work. The electric sun model was finally tested experimentally by the SAPPHIRE project, with funding from the International Science Foundation. Following confirmation of nuclear processes by other laboratories, success was announced at the annual Electric Universe Conference in 2019 at the University of Bath in England. Just to add icing to the cake, last month a paper was published in the Astrophysical Journal titled "The Sunward Electron Deficit, a Telltale Sign of the Sun's Electric Potential." Although the real significance of the discovery is lost on the authors, who insist that the heat of the Sun is causing the charge separation, what they measured was the drift current of electrons toward the Sun, which is characteristic of electron drift toward the anode in a discharge tube. The SAPPHIRE project showed nuclear transmutation production of heavy elements that are found in the solar spectrum. It shows all main sequence stars produce some radiant energy by the electric discharge, but most importantly, it catalyzes nuclear transmutations in their photospheres to produce the star's radiant energy and heavy elements together with neutrinos. Clearly, sunspots are dark simply because there is no radiation coming from within. So the complicated ad hoc life stories for different classes of stars is unnecessary, as is the evolutionary classification of stars into populations 1 and 2. Shortly, I will show that the electric model fits all stars. The James Webb Telescope, when successfully deployed, will allow us to see finer and fainter detail in the starburst regions of dense molecular clouds, where stars and gas giant planets are born. The twisting and turning glowing red filaments of constant width are like those in a novelty plasma ball. They are rotating Birkeland currents threading the gestating stars in those clouds. The stars grow in mass until they are born by a slingshot effect as the filament twists away. The enigma of the upper limit of star mass is simply answered. The James Webb Telescope should put this explanation beyond any doubt because gravity alone cannot produce such twisting and turning filamentary structures. It is hard to overstate the importance of evidence of helically twisted filament pairs and braids. The electric universe position has always been that the universe is one giant web of rotating electric currents that flow as filaments of helically twisted pairs and braids and manifesting that morphology at all scales. That stars are born in an intense magnetic pinching of a galactic Birkeland current, that every star is connected to the galactic circuit by a coaxial Birkeland current, that every galaxy is connected to a larger intergalactic circuit by coaxial intergalactic Birkeland currents. It is often very difficult to remotely observe an electric current in plasma dark mode passing through the diffuse interplanetary, interstellar, or intergalactic medium. For example, the discovery of interplanetary electric currents has only occurred when space probes have made unexpected in situ measurements. Nevertheless, it is often possible to remotely observe such electric currents because, for example, dust is aggregated to the current via Markland convection, or because the density of neutral atoms in the local plasma and the current density is sufficiently high for the generation of electromagnetic radiation in different parts of the electromagnetic spectrum. As I have often noted, radio astronomy is of particular importance because Birkeland currents typically emit synchrotron radiation in the radio spectrum. Of course, many observational challenges remain, not least because looking out into the universe from our place in the galaxy is like looking through a tangle of spaghetti, producing the cosmic microwave foreground. The observational evidence has already been accumulating for the existence of helically twisted filament pairs and braids at all scales, in solar flares, in star-forming molecular clouds, in supernovae remnants, planetary nebulae and other diffuse nebulae, within galaxies, connecting galaxies, and even galaxy clusters. Indeed, in June this year, phys.org reported on a finding by an international team of astronomers, and I quote, "mapping the motion of galaxies in huge filaments that connect the cosmic web, that these long tendrils of galaxies spin on the scale of hundreds of millions of light years, and that rotation on such enormous scale has never been seen before. The results published in Nature Astronomy signify that angular momentum can be generated on unprecedented scales." End quote. The phys.org report states, Noam Libeskind, initiator of the project at the AIP, says, and I quote, "Despite being thin cylinders, similar in dimensions to pencils, hundreds of millions of light years long, but just a few million light years in diameter, these fantastic tendrils of matter rotate. On these scales, the galaxies within them are themselves just specks of dust. They move on helixes or corkscrew-like orbits, circling around the middle of the filament while travelling along it. Such a spin has never been seen before on such enormous scales, and the implication is that there must be an as yet unknown physical mechanism responsible for torquing these objects." Of course, standard model astrophysics has no explanation for the observed helical and rotational motion. The phys.org report reveals how the angular momentum responsible for the rotation in a cosmological context is one of the key unsolved problems of cosmology. Of course, the problem remains unsolved because there is no tool or combination of tools in the standard model toolkit that can produce helically twisted filament pairs and braids, other than by a development of the physics of magnetic flux tubes, which are, after all, merely an effect of electric currents. The electric universe provides the answer. Rotating electric currents impart spin to galaxies, stars and planets, as first proposed by Dr. Bruce almost 80 years ago. It provides a simple explanation for Eddington's admission, and I quote, "The fact is that rotation of celestial objects is altogether mysterious." End quote. They are responsible for the remarkable alignment of galactic spins over cosmological distances, and, as Alfvén noted, they are responsible for transferring energy and momentum over large and very large distances. I predict that the James Webb Space Telescope, with its vast improvement in sensitivity and resolution, will reveal the existence of the connecting network of helically twisted filamentary pairs and braids ever more clearly. We will discover helically twisted filament pairs and braids everywhere we look. I make the same prediction for the Square Kilometre Array and the Extremely Large Telescope, and indeed every new telescope that significantly extends observational sensitivity and resolution. Returning to stars, two properties of stars we can measure from their light are luminosity and colour, or surface temperature. They are presented as a scatter plot in a Hertzsprung-Russell diagram, which, from an electrical engineer's point of view, is strangely mirror-reversed, with stars getting cooler as you go from left to right. There is, as Professor Don Scott writes in his excellent book, The Electric Sky, an elegant correspondence between the electric star plot and the electric sun model. The luminosity and colour of a star is due to plasma discharge phenomena in the ionosphere of a dense planetary-type body. All bright main sequence stars exhibit a phenomenon seen in the laboratory on the anode of a low-pressure gas discharge, where increasing current density causes bright secondary plasma tufts to progressively crowd the photosphere to give the appearance of granulation, eventually forcing the photosphere to expand and the spectrum to move from yellow towards blue and increasing the luminosity. Periodic behaviour observed in photospheres, like sunspots and helioseismic oscillations, are driven by resonant behaviour in the interstellar and interplanetary circuits. You may notice gas giant planets in the lower left-hand corner of the plot, together with the red dwarfs. That's deliberate. There are no failed electric stars. In that region, the bright photospheric plasma tufting reduces and disappears, and we see only the red anode glow of the red and brown dwarf stars enveloping their gas giant nucleus. Our Sun's more compact red anode glow is seen briefly as the chromosphere during total solar eclipses. The red anode sheath effectively increases the anode surface area of a star to collect sufficient electrons to stabilise it in the galactic circuit. Red giant stars have a gigantic glowing anode sheath. Their powerful stellar winds are caused by positive ions stripped from the atmosphere and body inside and accelerated away from the star by an electric field that strengthens as the anode sheath expands. The density of the ions passing through that anode glow contributes to their brightness. Variations in the plasma environment cause the observed changes in size and brightness of red giants and can produce dramatic flaring from electric arc ejection of matter from the star. The red giant Betelgeuse has recently demonstrated many of these phenomena. I predicted in 2008 that dim red stars will appear as giants. The other outliers in the Hertzsprung-Russell plot are the white dwarfs. Eddington wrote of white dwarfs when first discovered, quote, "Strange objects which persist in showing a type of spectrum entirely out of keeping with their luminosity may ultimately teach us more than a host which radiates according to rule." End quote. He got that right, ultimately. Here's the lesson. The luminosity in the Hertzsprung-Russell diagram has a mathematical relationship to the mass of the star. However, the luminosity of a white dwarf frequently differs by a factor of 100 from that of another with almost the same mass and apparent chemical composition. The first problem is that mass is undefined in physics. The second problem is that the universal gravitational constant, or big G, has a mathematical dimension of mass. And mass, according to m equals E over c squared, is an energetic variable. So the luminosity of a star can't tell us how much matter is in that star. The calculations that require white dwarfs composed of dense matter are worthless. White dwarf stars are a simple coronal discharge. It's like the faint white light we see around the sun in a total eclipse, which demonstrates the low luminosity of such a discharge. White dwarfs have no bright photosphere or chromosphere. The galactic electric field reaches down to the star and is strong enough to smear out the hydrogen spectrum and excite the spectra of heavier elements sputtered from the planetary body of the star. A plasma discharge can switch discontinuously between dark, glow, and arc mode, as we see in the abrupt, brilliant flaring and X-rays of faintly glowing brown dwarf stars, nova outbursts, and the sudden searchlight brilliance of a supernova. These outbursts are caused by exploding plasma double layers, where a cosmic circuit is suddenly opened and the store of electromagnetic energy in that circuit arcs across the switch. For a nova and supernova, the power stored in an interstellar circuit is unleashed on the hapless star, and heavy elements from its planetary core jetted into space, as Dr. Charles Bruce hypothesised. The structure of the interstellar circuit in that event can often be seen lit up around the remnant. In no circumstance does anything going on inside the star cause it to explode. Last, we come to the family of brown dwarf stars. These stars are arguably the most important target for the infrared James Webb Telescope because they are the most numerous and some of the closest stars to us. The telescope should confirm that all brown dwarfs are gas giant-sized bodies enclosed in a huge red anode glow. To give some idea, if Jupiter's present invisible plasma sheath were lit up, it would appear in the sky at opposition the size of the Sun. Brown dwarfs are simply small red giants. All red stars lack the transistor action of a bright main sequence photosphere, which steadies a star's radiance as their electrical input varies. So the phenomenal shrinkage in size of Betelgeuse over many years with steady luminosity, followed by its recent polar ejection of matter and dimming, is easy to understand. Like their giant brothers, brown dwarfs can be expected to show the same behaviours, and like red giants have an unexpectedly strong stellar wind for such a cool star. A lower mass brown dwarf in a binary system has already been found hotter than its higher mass companion. Such a reversal of temperatures with mass is not predicted by any theoretical model for brown dwarfs. So I expect new discoveries to confirm important parts of this narrative and not require any ad hoc additions to the electric universe explanation. In Part 3, I will talk about what the James Webb Telescope may tell us about the newborn planets and the subsequent formation of planetary systems. And it includes the formation of the solar system and the recent history of the Earth. It's a cosmology that involves us.